Hello guys, this is CodeNCode and this is new lecture for this basic algorithm series, and in this lecture we are going to see and study about the permutation and cost of the ith permutation or ith cyclic shift. So before we study, let me tell you why do we need to study this. This cost of a cyclic shift is a very common technique, and that is used in many problems that I've seen. And to be more precise, this is the most recent problem that I have seen in which we will be, or this technique is being used. This was from Codeforces around 648 div 2, and this was C problem. And in this problem as well, the same technique was used to solve this C problem from div 2. And instead of making an editorial for this problem, I thought it would be nicer, or it would be a better idea to tell you how this technique works so that you can solve the problems, which is this and 2 and 3 more problems I'll be showing you, which uses the same technique to be implemented. And the other problem that I see is, I guess, E problem from div 3, I guess. I don't know. We'll see that in a moment. So before studying what is the cost of the ith cyclic shift, let's see what is cyclic shift. If you already know, just you can simply skip this part. So the left cyclic shift is defined as this one. If you left shift this whole array one time, what would happen? This would be discarded and whole of this would be shifted towards left. This n-1 elements from position 2 to n will be shifted towards left. So this would be at the element at position 2 will be at position 1 after shifting, and this would be at position 2, this would be at position 3, this would be at position 4. And the element that we just discarded, because if you are shifting all the element towards left, there is no space for this to go left, so this will come out all the way to the new place which is created, because all of these elements are shifted towards left, so there will be an empty space built here. So this element will directly be going here. So basically on the left shift, this element will be shifted towards this, and the rest of these n-1 element will be shifted towards left one time. If you perform k times, what would happen? The first k element would be the last k elements, and the remaining n-k element would be the first n-k elements. So that would be the left shift. Now for the right shift, again what you do, you take the whole array and shift it towards the right, but again there is nothing right, so this element won't go towards right, but it would go towards the last element, because if you are shifting all of the elements towards the right, this place there will be a place left here which is empty, so this element will go there and the rest will be shifted towards the right. So you see 5, 1, 3 and 4 are shifted towards right, while this element has gone all the way towards the last element. So this is what right shift look like when you perform right shift one time. So the question is, what is the cost of the ith left or the right cyclic shift? Let me show you what do I mean by the cost, because the cost can be different depending upon the problem statement. So I need to be specific about the cost of the cyclic shift. So suppose the input is this, a permutation of length n, right? A permutation means all of the elements will be unique and will be from 1 to n. So n is 5 here, so this is a permutation of length n. So if I perform cyclic right shift 2 times, this would be the the updated or shifted array. So it would be 3, 5, 4, 2, 1. Now the cost of it is, we'll compare place by place. So at first position it have to be 1, at second position the element have to be 2, similarly for 3, 4 and 5. So at ith position element, the value at ith position should be equal to I. But here you see at position 1 there is 3, at position 2 there is 5. So basically first position doesn't match, second position doesn't match, third position doesn't match, fourth and fifth position doesn't match. So what does it mean? It means none of the element are there or are on their respective positions. So you need to change the first element in the array, you need to change the second element, similarly third, fourth and fifth. So you need to change 5 elements. That is why the cost is 5. Now let's take another example to make things more clear. Now this is after performing 3 right shift. Take this array and perform 3 right shift, 3 cyclic right shift, of course. Now the array would look something like this: 1 3 5 4 2. Now the cost is only 3 because after performing 3 cyclic shift, 1 is at position 1, so that's okay. 2 is not at second position, we are not having 2, so count plus plus, count plus plus again, because element doesn't match. Here it is matching, so no problem. Here it doesn't match, so 3. So the cost is 3 because you need to change 1 2 3 elements. So this is what I mean by cost of ith cyclic shift. Now the same idea has been taken and used in many problems. One of the problem is this. The problem which appeared in Codeforces round 648 div 2. This was a C problem. So basically you are given 2 permutation of length, permutation I guess, yeah, 2 permutation of length n, and you can shift either the first or the second permutation, doesn't matter. You can shift the first series in as many times as you want. You can perform cyclic shift towards left or towards right, doesn't matter. So you can same you can do for the second series. You can shift it towards left or towards right, how many times, doesn't matter. So what you have to do after shifting this series, the element must, ith element must match as much as possible. So after performing one shift, this I guess this series, if you perform one cyclic right shift, this series will look like 1 2 3 4 5 and leave the first series as it is. So above series is 1 2 3 4 5 and below series will also become 1 2 3 4 5. So you see first and second, third, first element match, second element match, third element match, and so on. Let me just increase the, yeah, now that's it. So I only need to perform one right cyclic shift, and after that the series that I will get will every place the ith element matches. So at first place I'll be having 1 1, at second place I'll be having 2 2 and 3 3 4 4 5 5. So all of the 5 places match. That is why the answer is 5, because 5 places are matching and we have to maximize the matching, and that is the concept of this whole problem, rotation matching. So you need to perform, you can perform right or left shift any number of times on the first series and on the second series, and you have to maximize the matching. Basically the ith element must match as maximum as possible. So we'll be using the same technique that we will be studying in the lecture for this concept. This was for this problem, and now take a look at this problem which appeared in round 615 div 3. It was E problem. So what you have to do, you are given a 2D array. In fact, what I'm going to do, you can see this problem is actually rated 1900, and after you study the technique that I'm talking about, you will be able to solve this problem literally very easily, and that is the goal of this lecture series, so that I can teach you algorithms and techniques of solving problems, so that you can take and learn those techniques and solve the problems by yourself. This problem, I'll be leaving the link into the description so that you can read about this problem and you can understand that, okay, this time this problem feels a bit difficult, and after studying the technique, and you will be able to solve this problem. And as shown again, it is rated 1900 problem, and it is div 3 E problem. Now after that, this is a problem appeared in long circuits. I don't remember in which circuit was it. This problem I don't actually remember. Circuit is actually like long challenge on CodeChef. So circuits on HackerEarth is same as long challenge on CodeChef. This is, I guess, 6-day challenge. So this problem also utilizes the same technique to solve this problem. There are q queries. Each time the xth element will be replaced by b, and then you have to tell what is the minimum or maximum. I think you have to minimize, or you have to minimize the cost of something. I'll be putting the link of this problem into the description so that you can read the problem and can understand how the same simple concept can be used to describe different problems and to solve different problems. In this lecture, it was only an introduction, so I'm not going to teach you in this lecture actually how to find the cost of the ith cyclic shift, but try to solve it yourself. And in the next lecture, I'll be teaching you how you can calculate the cost of the ith cyclic shift. For each I, you can calculate the cost of the ith cyclic shift in a single iteration of the whole array. So in big O of n time, we'll be able to count the cost of the first, second, third, fourth, fifth, sixth, nth cyclic shift. We'll be able to calculate for every single I. So in the next lecture, we'll be looking at the technique, how we'll be solving this problem, the cost of the how we'll be calculating the cost of the ith cyclic shift in big O of n time. So this was all for this lecture. If you have any doubt, query or suggestion, of course you can ask in the comment section or on the article that I've created for this course on the discuss.codechef.com, link of which I'll also be posting in the description of this video. So this was all for this lecture. Thank you guys for watching, and until the next video drops, keep coding. Thank you.